Hello friends, welcome to Kranthi Physics Tutorial. So today the Ohm's law. Ohm's law. So it is a very important law in the current electricity. Okay. So what is the statement of Ohm? So a conducting material, it has some potential difference between the two ends of its conductor, and therefore when there is a potential difference is there, then the current is flowing from the higher potential to lower potential. So Ohm states that, Ohm is a scientist name. Okay. So Ohm states that, so the statement of the Ohm's law is, whenever the current flowing through a conductor, the current flowing through a conductor, the current flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. Potential difference between the two ends of the conductor. Ohm's law statement. So the current flowing through a conductor is directly proportional to the potential difference developed. The current flowing through a conductor is directly proportional to the potential difference developed between the two ends of the conductor. So that is V is directly proportional to I. The potential is directly proportional to current. So therefore V equal to Ri, P equal to Ri. So this is the very important equation for the Ohm's law, the famous equation, that is V equal to Ri, Ohm's law equation. So V is directly proportional to I here, so I here, so V equal to Ri, where R is called as, so R is the proportionality constant here, and this R is called as the resistance. What we call that? Resistance. This R is called as the resistance, and the units for resistance are, so ohms. Ohm. So ohm is denoted by the letter this one. So this is the, so hat, looking like a hat symbol. So here V is, according to the Ohm's law statement, the potential developed across any portion of the wire or conducting material is directly proportional to the current flowing through the conductor. So V is directly proportional to I. We can write from according to this statement, and V equal to Ri. R is the proportionality constant here, and we call the R as resistance of that conducting material. So resistance means it opposes the flow of the current, it opposes the flow of the electrons. So every material, every body, every conducting material, so has some resistance to oppose the flow of the current, or to oppose the flow of the electrons through it. So that property is called as resistance. So here, according to this V equal to Ri statement, so how we can write R? So R equal to V by I. R equal to V by I. Potential by current. So V equal to Ri. So R is called resistance, and the units are resistance are ohm. The units of resistance are ohm, and the ohm symbol is like this, hat symbol. Ohm symbol is hat symbol. And you must and should remember, the resistance of any conducting material is depends on the, so resistance is depends on the depends on the, so nature of the material, nature of the material is depends on the nature of the material, how which type of material it is. So nature means which type of material, it is a brass or it is a steel or iron, so whatever it may be, that is the nature of the material. So it is depends on the nature of the material, and it is depends on the temperature. So temperature of the material, and it is also depends on the dimensions of the material. It is also depends on the dimensions of the material. So very important point. So the resistance is depends on the nature of the material, temperature of the material, and also it depends on the dimensions of the material. Dimensions means length, breadth, area. So resistance is depends on the nature, temperature, and the dimensions of the material. So this is about Ohm's law, and you must and should remember one important point. So whatever the materials, those obeys the Ohm's law, those are called as ohmic materials. Those are called as ohmic devices. So whatever the materials, those are obeys the Ohm's law, those devices are called as ohmic devices. So whatever the materials, so those materials so do not obeys the Ohm's law, those materials are called as non-ohmic materials. Non-ohmic materials are non-ohmic devices. Non-ohmic materials are non-ohmic devices. So the non-ohmic devices examples are semiconductors. So semiconductors are the example for non-ohmic device. That means semiconductors does not obeys the Ohm's law. Okay na? So this is about Ohm's law. Very important law. So finally, so what is the Ohm's law statement? So the current flowing through any conducting material is directly proportional to the potential difference between the two ends of that conducting material. So V equal to I, V equal to R. V is directly proportional to I and V equal to Ri. So R is the resistance. So R equal to Vi, and the units of resistance is ohm. Resistance are ohms, and the symbol of ohm is like this. It is a hat, looking like a hat symbol, and the resistance is depends on the nature of the resistance. So the resistance of unit length in unit area of cross section, unit area of cross section is called resistivity, and it is denoted by the letter rho. So the resistance often by a conducting material, so in a unit length and in unit area of cross section. So the unit area in unit area of cross, for example, this is a conducting material. So in a unit area of cross section and in a unit length, it has how much resistance. So that is called specific resistance or resistivity, and it is denoted by the letter rho, Greek letter rho. So here the units for specific resistance are, so the definition is the resistance of unit in a unit length. So that means the units are ohm meter, or it is also can be written as like this, ohm meter. So the units are ohm meters. So for which one? Specific resistance or resistivity. So the units of specific resistance or resistivity are, so according to the definition, so the resistance of a unit length. So that's why we can write the units according to the definition, ohm meter. So and also the ohm symbol is this one, so ohm meter. So you can write like this also. So now, what is the conductivity? What is the conductivity? So resistivity means, so resist the flow of the electrons or flow of the current. But here conductivity means it is any conducting material, it allows how much electrons or how much current through it. So conductivity means conduct the current. Resistivity means resist the current, oppose the current. So conductivity means allow the current. So here conductivity is exactly so opposite to the specific resistance or resistivity. So that's why the reciprocal of, we call it as the reciprocal of resistivity is called conductivity. The reciprocal of resistivity is called conductivity, and it is denoted by the letter sigma. So the reciprocal of resistivity is called conductivity. Why? Because the resistivity and conductivity both are in opposite. So that's why the definition of conductivity means the reciprocal of the resistivity is called as conductivity. So here conductivity is denoted by the letter sigma. So sigma equal to, so 1 by, reciprocal means here 1 by rho. 1 by rho. So reciprocal of resistivity is called as conductivity. And the units for conductivity. The units for conductivity are what? So this is the conductivity is the reverse of the resistivity. That's why, so if we can write ohm in reverse order, then what we get? Mho. We can write ohm in reverse order. What we get? Mho. MHO. So mho. Here ohm meter. So here the reverse of the resistivity is called as conductivity. So that's why here the units of the conductivity is, so ohm meter inverse or ohm per meter. Ohm per meter or ohm meter inverse. So ohm meter inverse are the units for conductivity. Why? Because it is exactly reverse to the reciprocal of the resistivity is called as conductivity. So that's why here the units are reverse of the ohm meter, that is mho, MHO. We can write the ohm letters in reverse. So MHO and meter inverse. So and also, or it is the conductivity also the another units, those are called Siemens per meter. S meter inverse. This is called as, S means, S stands for Siemens. S stands for Siemens. So here the another units of the conductivity are S meter inverse. Here S stands for Siemens. Siemens is a scientist name. Siemens is a scientist name. So Siemens per meter. So these are also called as units of conductivity. So here you must and should remember the one thing. So that is the, already I told you the resistance. The resistance is depends. The resistance is depends on the nature of the material, temperature of the material, and the dimensions also. And the dimensions means length, breadth, area. So resistance is depends on the nature of the material, temperature of the material, and dimensions of the material. But so the resistivity or specific resistance, is depends on the nature of the material and temperature of the material only. So the resistivity or the specific resistance rho is depends on the nature of the material and the temperature of the material only, but it is independent. So independent of dimension of the material. So independent of dimensions of the material. So you must and should remember this point. The resistance is depends on the nature, temperature, dimensions, but the specific resistance or resistivity is only depends on the nature and temperature only, but it is independent of the dimensions of the material, independent of the dimensions of the material. So here we can write one equation also for resistance. So here we can write the equation for the resistance, that is the resistance is depends on the nature, temperature and dimension. So here you remember, you must and should remember one equation, the resistance is directly proportional to the L by A. The resistance is directly proportional to the L by A. So that means the resistance of a material is directly proportional to the, so here from this what we can know, that resistance is depends on the dimensions, right? Dimensions means length, breadth, area. So here the resistance is directly proportional to the length, but the resistance is inversely proportional to the area of the material or area of the cross section of the material. So here R is directly proportional to L by A, and R is equal to rho L by A. So this is also one of the most important relation. So that is R equal to rho L by A. So here rho is the specific resistance or resistivity and L by A. So R equal to rho L by A. Why? Because the resistance is directly proportional to the length of the material conductor, and the resistance is inversely proportional to the area of cross section of the conductor. So therefore here rho is the proportionality constant. So therefore R equal to rho L by A. So here rho is the resistivity. Rho is the resistivity or specific resistance. Rho is the resistivity or specific resistance. So this is about Ohm's law, resistivity, conductivity, and on which factors the resistivity and the conductivity or the resistors are depends. So this is Kranthi signing off. Thank you.